Is my screen visible? Okay, in the last module we studied about the steering systems and the steering components and various steering systems that are present in the vehicles. And in the next module we are going to deal with the suspension and its components and the various type of suspensions used in the automobile and various types of suspensions used, and these are all we are going to deal in this module. So what is basically a suspension? So I have already told you we have so many mechanical components as well as we have the chassis, and on the chassis we are mounting various components, and the transmission occurs, transmission members are there, that is specifically the gearbox and the clutch, the propeller shaft, the differential, and it all then links to the axles provided at the provided, and the power is transmitted to the wheels. So that is how the power distribution or the power transmission is done, and each and every component is concentrated or weighed and set on the chassis. So a chassis is a rigid body, so there is nothing that holds the body or nothing that can bend the body. So it is a sturdy material, and it has to be provided in such a way so that there will not be any unnecessary when more load into the vehicle is mounted, it must not bend under that load, and for that purpose it is machined and produced as a single unit, and it's a sturdy material. But due to that sturdiness, in a road or when we are traveling the vehicle with a road, there will be unlevel terrains and even dips and humps over the road surface. And these irregularities in the road can stress or generate undesirable loads on the surface of the chassis or various components inside the vehicle, especially the wheels. So the wheels are the thing that is completely in contact with the road surface or the ground, and the rest all are then mounted onto the chassis, and the chassis is connected to four of the wheels in a vehicle. And due to that, on the unlevel terrain, various forces act against the tires, and these forces are then transmitted to each and every member inside the vehicle. So if we are not providing a suspension system, such loads can result in the breaking of chassis during multiple operations or even damage the components present inside the vehicle. So to prevent that, we are providing suspension. Suspension also results in effective handling of the vehicle or even reducing the vibration inside the body. So there is a stability inside the vehicle. So if you are riding a vehicle that has complete jerkiness or some has continuous vibration, there will be it will be difficult to control also and to steer itself. And to prevent that, we are providing suspension. Suspensions can be many types. So there will be in the shape of a coil, that is a spring, coil spring in the shape of a coil spring, or in the case of a telescopic shock absorber, which we'll be studying. Then in the model of a leaf spring, That also I will tell you how it is shaped. And these are all providing a cushioning effect. So it's a cushion. So in a cushion, if we are applying a force, it absorbs a certain amount of the force that is incoming. Same function is done by the suspension. So for different purposes, various types of suspensions are used to reduce the load that is coming onto the wheels and thereby transmitted to various components inside the vehicle. Okay, and various geometries that assist in suspension are wheel camber, caster, and kingpin inclination. So in the last module, I have told you what is wheel camber, caster, and kingpin inclination. So camber is nothing but the turning when we are looking from this side. When you look at this figure, when you are looking from this side, and an inclination is provided to the wheels with respect to the vertical from this direction, with respect to the vertical from this direction. That is known as camber. So we have studied about positive camber and negative camber. Another one is caster. So when you are looking from this direction, an inclination provided uh, by the wheels, and that is known as caster. And then comes the kingpin inclination. So there is a component kingpin inside here, and the kingpin making an inclination with the sufficient vertical when looking from this side, from the sideways, and that is known as kingpin inclination. So these three you can refer to the previous module to understand what is wheel camber, caster, and kingpin inclination. So these geometries that are present in steering geometry are also present in suspension geometry. So these also help in suspension. So you can say other this is kingpin inclination, what is shown here. This is toe, means toe in and toe out, which you can set the wheels apart facing in a V shape like this or like this. So that is determined by toe in and toe out. These are also contributing to the suspension inside the vehicle. Then it is essential for suspension members to maintain these settings throughout their service life. So during multiple operations, a slight change in various of these geometries can occur. So during service, we are setting it back to the original position to perform or for the perfect functioning of the suspension. For that purpose, we are setting these geometries, and these are set throughout the service life. So until it is being replaced, these components are used throughout the vehicle for better suspension qualities. Unfortunately, the pivoting and swelling joints of the suspension system are subject to both wear and damage, and therefore must be checked periodically. So there will be so many points. So there will be joints here. You can see one joint here. Similarly, it is present here also. And these joints are subjected to wear and damaging, as these are mechanical components, and continuous operation can result in rubbing of these metals with each other and wearing of the material from the bearings and such systems. And these have to be checked periodically and replaced if necessary for better suspension qualities. Then some of other terminologies that are present inside the suspension are swivel joints for kingpins, pivot center, contact patch, contact centers, and then track. So these are some of the other terminologies apart from caster, camber, and kingpin inclination. So we'll be discussing each one. So this is what is a swivel joint. So what is the definition? These are points about which the steering wheel stub axles pivot. Okay, these are steering wheel stub axles pivot. That points are known as swivel joints or kingpins. So you can look at a figure here. This is the wishbone type arrangement that we have studied in the previous module. So it's in the shape of a wishbone. So there will be two arms like this, in the shape of a wishbone, and it is directly connected to the wheel hub in this manner. You can see the manner in which it is connected, and this is how this is also a wishbone when we are looking from the side, just from the top and another. So these are all in this swivel ball joint wishbone suspension and steering. So this is in the shape of a wishbone. So how the suspension in a wishbone, I will show you in a video later. And this one is the kingpin suspension that we have talked about earlier. So here the wishbone is being replaced by a kingpin. Kingpin is nothing but a, you can see here, the kingpin is nothing but a bolt. So you can see a bolt here. So it is then assembled into this slot provided here at the wheel hub. So here from this diagram you can see the kingpin is then mounted into this part here. So this is how the swivel joint or kingpin joint is replaced by the wishbone. Okay, the wishbone is being replaced by the swivel joint or the kingpin joint here. So an example of that is shown here. So this is the kingpin here. This is the wheel hub, and onto the wheel hub we are mounting the kingpin here. Okay, and this is the axle. Then it goes to the axle. The kingpin then connects the axle with the wheel hub instead of two arms of the wishbone. So instead of providing two arms, a single component is responsible for the tethering of the wheel hub and the axle. Okay, this is how the swivel joints or the kingpins are mounted. Next one is the pivot center. So the point where the swivel ball joint axis or the kingpin axis projects and intersects the ground. So there are two types of joint here: swivel ball joint axis and kingpin axis. Okay, so here you can see a kingpin. So we are mounting a bolt that is known as kingpin, and such an arrangement is known as kingpin axle. But instead of using a kingpin, we are using a ball joint. So it will be in the shape of a ball, and we are using a ball joint. Then it's known as a ball joint. It's known as a ball joint axis. Okay, so it will form a ball joint axis. This is the kingpin axis. So the vertical line that passes through the kingpin is known as kingpin axis. While when a ball joint is used and the axis that passes through the vertical line passes through the ball joint, then it is known as the ball joint axis. So through this axis, so the point where the ball joint or the kingpin axis projects and intersect the ground. So that is what is known as pivot center. So it has to be projected and then intersect to the ground. So I can see two figures here. So in the first figure, you can see, so this is a kingpin and this is also a kingpin. And from this kingpin, if we are drawing an axis, the axis goes and then intersects the ground. So it is intersecting here, and this point is known as pivot point. So it will be underneath the tire. So the contact area of the tire comes through this area. This is the area that is shown, and almost at its center is the pivot center. Okay, it is shown as patch area here, and almost at its center is the pivot center, or it is the axis, and it then intersects the ground. So once it intersects, it makes a point, and that point is known as pivot center. So if the kingpin is slightly inclined in such a manner as shown here, then the axis also inclines through the kingpin, and then it comes into contact at a rather other area than the patch area. So it has to intersect the ground. So this point is known as pivot center or the pivot point. So you can see here pivot point. Okay. Next is contact patch. So then from the name itself, you can know that it is the flattened crown area of a tire which contacts the ground. So the area underneath the wheel that is coming into contact with the ground is known as contact patch. So you can see this is a wide tire. So this will be a wide tire. This is a smaller tire. So you can see how the contact patch varies. So this has a large volume of contact patches coming onto contact, but a little distance only. The contact patch length is much smaller than compared to a wider tire here, but the area of contact is more in a smaller tire. Okay, you can see the area here. So it will be a longer part of the tire is being contacted to the road surface, and here a shorter distance but a large area is coming into contact with the ground. So this is the contact patch. It depends upon the tires that are used inside the vehicle. Next is contact centers. So we have already told about contact patch, and from that contact patch, a center is derived. So the center of the contact patch is known as contact centers. So it is termed as, this is a tire contact patch central point which is in contact with the ground. So it is a central point almost here. Okay, so this is the ground here. Okay, this is coming into contact, shown like this. Instead of a ground, a glass is shown, but the essence is same. Here the tire is coming into contact with the glass surface and it forms a contact area, and the center of the contact area is known as its contact center. The center of the contact area is termed as its contact center. Next is track. So in the previous module, we have studied a derivation and I have told you about wheelbase and track. So track is nothing but when we are looking from the front of the vehicle, it is the transverse distance between both the steering wheel contact centers. So the wheel contact happens through the center of the wheel as shown here. It is happening at the center and the center points are there. Okay, from the contact area we have contact centers. So from that contact center, from one contact center to other contact center of the wheel, if we are taking front or back, it will be the same. Even in the rear and the front, the contact centers are the same, and the distance between the contact centers in transverse direction, that is in this way, not in this way. Okay, there's a transverse distance between the wheel contact centers. So from one center to other center, not from front to rear, but from front right wheel to the left wheel, or from rear left wheel to right wheel. So that is what is known as track. So it is shown as track here, and the distance from the contact center of front and rear tires are known as wheelbase. Okay, so this is track and this is wheelbase. Next is a type of suspension that was once common, and it's still also being used. It is known as Macpherson's Strut suspension. Macpherson's Strut suspension. So instead of using a wishbone type of suspension, this is the wishbone type of suspension that is shown here, and it is known as a double wishbone here. So this is a wishbone, and this is the Mcpherson Strut type suspension. So this is the Mcpherson. So you can see the difference from looking at the figure itself. So here also you can see this is the Mcpherson type. Okay, instead of using the double wishbone, okay, it is using underneath part is looking like a wishbone, but it's not. This is the steering axle. Okay, front axle. This is the axle through which the wheel is mounted. That is what is shown here. And this is the shock absorber or the suspension component that is present inside the Macpherson. So we have to study about the Macpherson suspension, and it is known as Macpherson strut suspension or Macpherson friction and spring offset suspension. So that is how it is known. And this Macpherson system is a replacement of a double wishbone, wherein the double wishbone has two wishbones and the coil spring is mounted in between the wishbones as shown here. But here the complete body rests on the Macpherson coil spring, and then it is coming into contact with the wheel hub. So you can see this is the wheel hub. In the wheel hub, the suspension component is directly mounted to the wheel hub, and from the wheel hub, the front axle. So this is what the front axle is looking like, and this is the car frame that is mounted onto the lower control arm of the Macpherson strut suspension. It is known as the control arm, and it is present beneath the car frame, or the car frame rests on the control arm. So the control arm is also responsible for slight suspension action inside the suspension component. So it will bend a little towards the downward direction for absorbing such loads that is coming onto the contact of the car frame to prevent any damages occurring to the car frame, or it is also known as the chassis. So the chassis is mounted on the lower control arm while the body is resting on the shock absorber or the spring of the Macpherson strut suspension. So you can watch the video.
Macpherson strut suspension. The Macpherson strut is the most widely used front independent suspension system that the wheels are allowed to move independently.
This is how it works.
A Macpherson strut suspension combines two major functions. As a steering rod, as a suspension dampener. Basic Macpherson strut design. Let's look at the major parts of a Macpherson strut suspension. A single control arm connected to the bottom of the wheel hub. A shock spring combination protruding from the top. The Macpherson strut combines the coil spring and shock absorber into an integrated unit. This gives a more compact and lighter suspension framework that can be used for front-wheel drive vehicles. A steering link connected to the wheel hub. A Macpherson strut suspension may also include an anti-roll bar, attached by a ball-jointed rod, to the spring damper. The advantage. The simplicity of the Macpherson strut suspension is its major advantage. The Macpherson strut suspension effectively combines spring, strength and stability and low manufacturing cost. Without the need for a separate upper control arm, the Macpherson strut requires less components to produce, which is cheaper to make, more lightweight, and smaller than other suspension systems. The reduced unsprung weight also allows the vehicle to accelerate at a faster speed. Mcpherson strut suspension is great for front-wheel drive, since the space it allows for the drive shaft. There is nothing in the center, so it can easily accommodate a drive shaft there. The disadvantage: the Mcpherson strut suspension has a lengthy vertical assembly, which would run into problems if needed to lower the vehicle. Thus it's not suitable for a race car or sports car, as these types of vehicles are often lowered closer to the ground. Due to the simplicity of the Mcpherson strut suspension, it is small camber changes with body roll. Because the strut is moving linearly, the wheel gains camber to a certain extent, and after that will start to lose camber. This could hamper a car's handling, and experience a lot of body roll and cornering. This makes the Mcpherson strut more inferior to other advanced suspension systems, such as the double wishbone suspension. Nevertheless, the Mcpherson strut suspension still remains a brilliant invention, which effectively combines spring, strength and stability and low manufacturing cost.
Okay, so that is what it's shown in the video, how it works and what are its advantages and disadvantages. So that we'll be discussing in detail. So one of the advantages they have told was that it is cheaper and lighter than double control arm wishbone. So you have seen the wishbone here. So this is the double wishbone type suspension, and the Macpherson here is lighter due to. So here you can see the double wishbone itself is a sturdy material, and it is a it will contribute much weight when compared to this type of arrangement inside the Mcpherson strut. So for that purpose, it is cheaper and lighter, thereby reducing the cost of installation of the Macpherson strut suspension onto the vehicle. Then another advantage they discussed was the it is great for a front wheel drive due to large space. So you can see the arrangement itself. So you can see here there is a large space. So if you are removing this, this is what the axle is there. And when we are removing the axle, you can see there will be a large area we will be or a large volume is present inside the Macpherson strut suspension rather than the double wishbone. So you can see the limited area is only present inside the double wishbone, but a large area is present between the Macpherson strut suspension. So for front wheel drives, so in front wheel drive, the drive is occurring in the front wheels. So the engine is directly coupled to the front wheels of the vehicle. So that is what is known as front wheel drive. So when such an arrangement is given, uh, a Macpherson strut suspension is much efficient than a double wishbone. So in a double wishbone, you can see this coil spring comes in between the front wheel drive. If you are coupling a drive here, you can't provide a drive, but rather rear wheel vehicle drives are common in double wishbone. So you don't have to provide this shaft, but when we are providing a shaft to the rear wheels, the vehicle is propelled forward and the front wheels are free to rotate. Okay, that is how in double wishbone rear wheel drives are done. But in Macpherson strut, you can do front wheel drive. So what is the advantage of front wheel drive? So we know various components that are present for rear wheel drive. So from the gearbox, it goes to the propeller shaft, from the propeller shaft to the differential, and then to the rear wheels. So that is how power is transmitted. But these long distance of power transmission results in the loss of transmission power. Okay, this loss can be compensated for front wheel drive. So we don't have too much distance from the engine and the front wheels. That is what is the difference between front wheel and rear wheel. And if you want a front wheel drive, best suspension is the Macpherson strut type suspension. Okay, that is another advantage. Then about the disadvantages, it is taller than double arm double wishbone type suspension. So being longer means or taller means the body is mounted at a height, certain bigger height than the vehicle. So what happens is that when you're mounting a body up more higher than the road surface, there is a problem of the airflow underneath the car. So once that airflow pressure is increased, the car can flip upwards and results in the rolling of the car, and this is undesirable. For that purpose only, we are lowering the distance of the car or the ground clearance of the car to a particular limit. Okay, so for that purpose, this type of suspension is really bad. And then comes the small camber changes. So they have discussed about the camber. So you know that camber is the, when looking from the front, camber is the inclination of the tire provided with the vertical. So when camber gains, so you can see that how the tire was hitting this coil spring of the suspension. So when hitting the coil spring of the suspension, sufficient camber is negated. So there is no gain. So when you are releasing it on the road, it becomes straight due to the striking of the wheel with the coil spring. So when this happens, the camber gain that we have intended to use will not be efficient, especially during cornering. So in cornering, I told you there is a slip angle, and once it exceeds the slip angle, the body rolls. And this rolling capability is then further reduced by increasing the camber. That is how we reduce the rolling of the vehicle. And due to no camber gain inside the Macpherson strut type of suspension, the body can roll and the slip angle generated will be much higher than in other vehicles. So that is one of the another problem with the uh, Mcpherson Struct type of suspension. So another problem is that due to the body being mounted on the suspension arms, uh, smaller vehicles or lighter loads can only be mounted onto the Mcpherson Strut type suspension. So that is one of the disadvantages. So in heavier vehicles and all, we can't use it because the complete weight of the body is being mounted on the suspension coil spring itself. So coil spring has to be provided with sufficient strength, and when we are providing sufficient strength, the coil action or the spring action does not take place, and this is undesirable, and hence this suspension system is uh, this suspension system has a disadvantages. Okay. Next are some of the terms that we will be discussing now. So this is called a roll center, and another one is roll axis. So roll center and roll axis is nothing but, so you can see a line going through here, okay, through the centers of the wheel and the track. Okay, this is the track axis, or from the front wheel to front wheel and the rear wheel, and its centers and this center. Okay, this is the propeller shaft direction. So this is a bending moment is occurring here. So how does this occur? So when imagine the vehicle taking a curve in this direction, taking a curve in the left direction. So once it takes, the vehicle tends to move or roll in the opposite direction. Okay, if it is going left, it will be tending to roll in the sideway direction once the speed increases and the slip angle increases. So that is how rolling is done. So if it turns left, it will roll right, and if it turns right, it will roll left. Okay, that is how it happens. So it can turn or roll in a sufficient motion, and that is due to the bending moment that is occurring inside the vehicle. So the centers at which the rolling centers, the centers at which this roll occurs are known as roll centers, and such a roll center is present at the front wheel and also at the rear wheel. So these are the two roll centers that are present, and the axis through which the roll centers pass through is known as a roll axis, preferably in the propeller shaft axis. Okay, so this is the roll center of the rear wheel, and this is the roll center in the front wheel. So here, okay, this is the front wheel, and here it is rear wheel. So you can see R here and F here. F is for front and R is for rear. So roll center, and this is taking a curve. Okay, this is the curve it is shown, and the axis that passes through the roll centers are known as roll axis. Okay, time is almost up, and I will wind up today's class.